The summer heat hung heavy over the French countryside in August 1943. At a remote Luftwaffe airfield, hidden among the hedgerows and farmland of occupied France, something extraordinary had just arrived. Word spread quickly through the technical staff. An American fighter had been forced down. The pilot was captured. But more importantly, the aircraft itself was largely intact. For the German engineers who had spent months hearing impossible reports about this massive American fighter, it was like Christmas morning. Finally, they would have answers. Finally, they could understand how the Americans had created this beast that was changing the air war over Europe. Oberleutnant Werner Schulz wasn't a warrior in the traditional sense. He had never shot down an enemy aircraft. He had never dropped bombs on enemy positions. But in his own way, Schulz was fighting a war just as important. As the chief technical officer of Jagdgeschwader 26, one of the Luftwaffe's most prestigious fighter wings, Schulz's battlefield was the workshop and the hangar. His weapons were calipers, micrometers, and mathematical calculations. His mission was to understand the enemy not through combat, but through cold, hard engineering analysis. And on this August day in 1943, he was about to receive intelligence that would fundamentally alter his understanding of the war Germany was fighting. When the call came through at just after 4 in the afternoon, Schulz was in his office, buried in paperwork about spare parts shortages and maintenance schedules. The voice on the other end of the line was excited, almost breathless. An American P-47 Thunderbolt had been captured. The pilot had gotten disoriented in cloud cover during a bomber escort mission and made an emergency landing at what he thought was a friendly airfield. By the time he realized his mistake, German soldiers were already surrounding his aircraft. The pilot, Second Lieutenant William Roach of the 358th Fighter Squadron, was now in custody. But more importantly for Schulz, the aircraft was his to examine. Schulz had been waiting for this moment. For months, intelligence reports had been flooding in about the P-47 Thunderbolt. The accounts seemed almost fantastical. German pilots reported an American fighter that was impossibly large, absurdly heavy, and yet somehow fast enough to catch their best aircraft. They spoke of a machine that could absorb damage, that would obliterate a Messerschmitt or Focke-Wulf, and still fly home. They described firepower so overwhelming that even brief bursts would shred German fighters. Some reports claimed the P-47 could maintain full power at altitudes where German engines were gasping for air. It all sounded like propaganda, like the desperate exaggerations of pilots trying to explain their defeats. But the reports kept coming from too many experienced pilots with too much consistency. Something about the American fighter was different. As Schulz drove to the airfield where the captured P-47 sat on the tarmac, he felt a mixture of anticipation and dread. Anticipation, because as an engineer, he loved solving puzzles, and this aircraft was the ultimate puzzle. Dread, because some part of him, the part that lived in numbers and equations rather than ideology and propaganda, suspected that what he was about to discover would confirm his worst fears about Germany's position in this war. When he first laid eyes on the P-47, Schulz's initial reaction was the same as every German pilot who had encountered one. The thing was grotesque. It was an obscenely fat, ungainly flying milk bottle, as the Luftwaffe pilots had nicknamed it. The Fliegendflasche, the fuselage was massive, built around an enormous radial engine that made the aircraft look like someone had stuck wings on a barrel. Fully loaded, intelligence suggested the P-47 weighed nearly 8 tons. 8 tons! For comparison, the Focke-Wulf FW-190, Germany's frontline fighter that was considered quite heavy by European standards, weighed about 4 tons fully loaded. The P-47 was twice as heavy as Germany's premier fighter. Looking at it sitting there on the French tarmac, Schulz understood completely why German pilots had mocked it. It looked like it had no business being in the air at all. But Schulz was a scientist first, an engineer who believed in numbers and physical reality rather than aesthetics or first impressions. He didn't care what the aircraft looked like. He cared what it could do. And more importantly, he cared what its construction revealed about the industrial base that had created it. As he approached the aircraft, with his team of mechanics and technicians, notebook in hand, Schulz prepared to conduct the most important examination of his career. They started with the heart of the machine. The cowling was carefully removed, a process that took longer than expected because the Americans had designed it with quick-release fasteners that the German mechanics weren't familiar with. When the cowling finally came off and the engine was revealed, Schulz and his team stood in silence for a long moment. The engine was enormous, 18 cylinders arranged in 2 rows of 9, creating the radial configuration that explained the P-47's bulky appearance. The Pratt Whitney R-2800 double wasp. Even the name sounded aggressive. But it wasn't just the size that stunned Schulz. It was the quality. Every component was machined to tolerances that German factories were increasingly struggling to maintain. The cylinders were uniform, perfectly balanced, each one a masterpiece of precision manufacturing. The crankshaft looked like it had been crafted by a master machinist working with unlimited time and resources. The cylinder heads, the valve train, the connecting rods, every single component spoke to manufacturing standards that Germany could once match, but was now struggling to maintain. This wasn't an engine built by a nation at war, desperately scraping together resources and making compromises. This was an engine built by a nation operating at peacetime quality standards, even while fighting a global war. Schulz pulled out his notebook and began calculating. Based on the displacement of the engine and its design parameters, this power plant had to be producing at least 2,000 horsepower, possibly more when the Turbo-Supercharger system was functioning at full capacity. He could see the turbocharger ducting, snaking down through the fuselage, an engineering marvel in its own right that he would examine in detail shortly. 2,000 horsepower. The number made his stomach tighten. For comparison, the BMW 801 radial engine that powered the FW190 produced about 1,700 horsepower at maximum output. And that was pushing German engine technology to its absolute limits. The BMW 801 was the culmination of years of development, incorporating every trick and technique German engineers knew to extract maximum power from internal combustion. And here was an American engine producing 20 to 30% more power, and doing it with what appeared to be effortless ease. But what really disturbed Schulz was what the engine didn't show. He examined the construction carefully, looking for signs of shortage accommodations, the kind of compromises German factories were increasingly forced to make. Lower-grade materials used where high-grade alloys should be. Simplified manufacturing processes that sacrificed quality for speed. Substitutions made because critical materials weren't available. He found none of this. The R-2800 was built with high-grade aluminum alloys throughout. The bearings were precision ground. The fasteners were high-tensile steel. Every component showed evidence of a supply chain operating without critical shortages, without desperate substitutions, without the constant compromises that characterized German war production. This engine was built the right way, not the expedient way. One of Schulz's assistants, a mechanic named Karl, who had worked on German aircraft engines for more than a decade, pointed to something that caught his attention. The engine's cylinders were individually removable. If one cylinder was damaged or developed problems, a mechanic could replace just that component without having to disassemble the entire engine. It was brilliant design, the kind of thing that seemed obvious once you saw it, but required sophisticated engineering to implement properly. It meant faster repairs, less downtime, more aircraft remaining operational at any given time. German engines required extensive disassembly for major repairs. A damaged cylinder meant taking the entire engine apart, a process that could take days. The Americans had designed their engine assuming that maintenance would happen frequently in combat conditions and needed to be as efficient as possible. It was the difference between an engine designed by engineers who understood operational realities and one designed by engineers working under different constraints. But there was something else that made Schulz's stomach tighten with dread. Something that went beyond even the impressive basic engine design. The real secret of the P-47's performance wasn't just the R-2800, it was the Turbo-Supercharger system. Schulz had read intelligence reports about this system, but seeing it in person was entirely different. A complex network of ducting snaked from the engine down through the fuselage to a turbine mounted in the rear of the aircraft. The exhaust gases from the engine, instead of simply being vented overboard, were channeled through ducting to spin a compressor turbine at speeds exceeding 20,000 revolutions per minute. This turbine compressed incoming air and forced it back into the engine, maintaining sea-level air pressure even at high altitudes. The engineering was staggering. The exhaust gases were extremely hot enough to melt steel if the ducting wasn't properly designed. The turbine had to spin at speeds that would tear apart inferior bearings in seconds. The entire system had to be precisely calibrated. Too much boost pressure, and you would blow the engine apart. Too little, and you lost the performance advantage. The ducting had to withstand not just heat, but also vibration, thermal expansion and contraction, and the stresses of combat damage. And all of this had to work reliably, mission after mission, in the hands of pilots who might be fresh out of flight school. German engineers had experimented with turbo-superchargers. Schulz knew this because he had reviewed some of the research reports. Multiple projects had been initiated. The Daimler-Benz DB624 was a DB603 fitted with both a two-stage mechanical supercharger and a turbo-supercharger. It promised 1,900 horsepower. The project was abandoned in April 1943. The DB625 was a DB605 with a turbo-supercharger, abandoned. The DB626 was a DB603 with twin turbo-superchargers, abandoned in November 1942. Project after project had been initiated and then cancelled. The technical challenges were too great. The materials were too difficult to source. The manufacturing was too complex. The development time was too long. Germany simply couldn't field a working turbo-supercharger system while also trying to maintain production of existing aircraft and engines. But here it was, in an American fighter, not a prototype, not an experimental aircraft being tested under ideal conditions, a production model, one of hundreds being built every month. The P-47 sitting on this French airfield was one of thousands that would eventually be produced. And every single one of them had this sophisticated turbo-supercharger system installed as standard equipment. Schulz did the calculations, working through the mathematics of thermodynamics and fluid dynamics that governed high-altitude engine performance. With this turbo-supercharger system, the P-47's engine could maintain full power at altitudes where German fighters were gasping for air. Above 25,000 feet, the FW-190 and the Messerschmitt Bf-109 lost significant performance as their mechanical superchargers struggled in the thin air. The P-47 would be hitting its stride, fast, powerful, and completely dominant in the high-altitude realm where German fighters had to operate to intercept bomber formations. One of his assistants, a young engineer named Hans who had joined the Luftwaffe straight out of Technical University, asked the obvious question that was on everyone's mind. Could Germany replicate this system? Could they take what they learned from this captured aircraft and build their own turbo-supercharged fighters? Schulz shook his head slowly. Not with their current manufacturing capacity. The turbo-supercharger system alone required precision machining capabilities, high-grade heat-resistant steel alloys for the turbine and ducting, and thousands of man-hours of skilled labor per unit. Germany was already struggling to produce enough basic aircraft to replace combat losses. They were already dealing with critical shortages of skilled labor as experienced workers were drafted into the Wehrmacht. They were already rationing high-grade steel and aluminum for the most critical applications. Adding this level of complexity to their fighter, production would be beyond their current capabilities. Even if they could figure out the engineering, even if they could create working prototypes, scaling up to mass production would require resources and manufacturing capacity that Germany simply didn't have. The realization was crushing. The Americans hadn't just built a better fighter. They had built a fighter that represented a level of industrial sophistication that Germany couldn't match. It wasn't about superior design or better engineering principles. German engineers were brilliant. The Luftwaffe had some of the most advanced aircraft designs in the world. But engineering brilliance didn't matter if you couldn't manufacture the designs in sufficient quantities. And the P-47 represented manufacturing capability on a scale that Germany couldn't hope to achieve. After examining the engine and turbo-supercharger system, Schulz turned his attention to the airframe itself. The P-47 they were examining had taken significant battle damage. Cannon shells had torn through sections of the fuselage. Machine gun fire had riddled the wings. There were impact marks, holes, and damaged structural members throughout the aircraft. And yet this aircraft had flown back from its combat mission and made a controlled landing. The pilot had walked away without serious injury. A German fighter with similar damage would have fallen from the sky in pieces. Schulz examined the damage patterns carefully, taking measurements and photographs, making detailed notes about every impact point. Multiple 20mm cannon hits, the kind that would typically shred a German fighter. But the P-47's structure had absorbed the hits. The heavy-gauge aluminum skin was substantially thicker than that used in German fighters. The internal framing was robust, with redundant structural members that allowed the aircraft to maintain integrity even when primary structures were damaged. The control systems had redundancy built in, with backup cables and mechanisms that would keep the aircraft controllable, even if primary controls were severed. He pulled out damage reports from various Luftwaffe units that had encountered P-47s in combat. The reports painted a consistent picture. Time and again, pilots reported pumping cannon fire and machine gun rounds into P-47s and watching in disbelief as the American fighters continued to fly. In some cases, pilots reported seeing parts of the P-47's tail section shot away, entire sections of wing damaged, engines visibly leaking fluids. And yet the American aircraft continued to fight, or successfully disengaged, and flew home. The reason was now evident to Schulz as he examined the captured aircraft. The P-47 was built like a tank, where German fighters optimized for weight savings and agility, accepting reduced durability in exchange for performance. The P-47 was designed to absorb punishment and keep flying. The cockpit armor was extensive. Thick steel plates protected the pilot from multiple angles. The windscreen was armored glass, far thicker than anything in German fighters. Behind the pilot was a plate of armor that would stop anything short of a direct cannon hit. Below the pilot, armor protected against ground fire. The Americans had clearly designed this aircraft with pilot survival as a primary concern, not an afterthought. But most importantly, the R-2800 radial engine itself served as a massive shield. Unlike the liquid-cooled inline engines in the Bf-109 and FW-190, which had vulnerable coolant systems that would cause immediate engine failure if punctured, the radial engine had no such weakness. You could shoot cylinders entirely off the R-2800, and it would keep running. A liquid-cooled engine hit in the cooling system would seize up within minutes as it overheated. The radial would keep going. Schulz found documentation and photographs showing that P-47s had returned to base with multiple cylinders destroyed, fuel tanks punctured, control surfaces shot away, and massive structural damage. German fighters with similar damage simply didn't make it home. One of the younger engineers made an observation that showed he was thinking like a German engineer rather than understanding the American approach. The P-47 was over-engineered, he said. The Americans had added weight for durability that could have been used for performance. They could have made the aircraft lighter, more maneuverable, better in a turning fight. Why waste all that weight on armor and redundant systems? Schulz nodded slowly. Yes, the young engineer was right in a sense. The P-47 was over-engineered by German standards, but the Americans could afford to be. They had engines powerful enough to carry the extra weight. Germany didn't. German fighters had to optimize for weight because they lacked the engine power to overcome inefficiencies. It was a fundamental difference in design philosophy that went beyond any single design choice. Germany built aircraft at the edge of what was technically possible, squeezing every ounce of performance from limited resources, accepting trade-offs and compromises because they had no choice. America built aircraft with massive safety margins, compensating for any design inefficiencies with brute force, with more power, more materials, more margin for error. And brutally, the American approach was working better. The survival rates of American pilots were higher. The operational readiness rates of American fighter groups were higher. The simple ability to keep fighting despite damage was giving the Americans an enormous advantage. Schulz moved on to examine the P-47's armament. 8 Browning M2 50 caliber machine guns, 4 in each wing. Each gun had approximately 400 rounds of ammunition. Total ammunition load, 3,200 rounds. The rate of fire for all 8 guns combined was over 100 rounds per second. Schulz sat with these numbers for a long moment, working through the implications in his mind. The firepower was devastating. A 1-second burst would put 100 heavy projectiles into a target. A 2-second burst, which was typical for a firing pass, would launch 200 rounds. Even a brief encounter would see hundreds of rounds fired. German fighters typically carried 2 or 4 machine guns, plus 1 or 2 cannons. A Bf-109 might have 60 rounds for its cannon, and 500 rounds for its machine guns. Once that ammunition was expended, which could happen quickly in the intensity of combat, the pilot had to return to base. The P-47 pilot could fire almost continuously for 30 seconds before running dry. In practice, that meant multiple long bursts across several engagements before ammunition became a concern. The American pilot had the luxury of not having to be conservative with ammunition. He could fire longer bursts, could engage multiple targets, could afford to spray bullets in the general direction of an enemy, and still have plenty left over. But it wasn't just the quantity. Schulz examined the 50 caliber rounds themselves. They were heavy, high-velocity projectiles that could punch through armor and structural components with ease. The 50 caliber round was originally designed as an anti-material weapon, meant to destroy light vehicles and equipment. Adapted for aircraft use, it was devastating. The projectile weighed more than twice what a standard rifle-caliber machine gun round weighed, and it was fired at velocities that gave it tremendous kinetic energy. When it hit an aircraft, it didn't just punch a hole. It transferred massive amounts of energy into the structure, causing damage far beyond the immediate impact point. A burst of 50 caliber fire could tear structural members apart, could smash through armored components, could shred control surfaces and fuel systems. He had read reports from pilots describing the effect of P-47 fire as a wall of lead. Now he understood why. With 8 guns converging at a focal point a few hundred meters ahead of the aircraft, anything caught in that cone of fire would be absolutely shredded. German aircraft, with their lightweight construction and limited armor, would disintegrate under this kind of firepower. The P-47 didn't need to be precise in its gunnery. It just needed to get the target generally in front of it and hold the trigger down. The sheer volume of fire would do the rest. Schulz made notes in his report. His recommendation would be stark. Avoid head-on engagements with the P-47. The probability of surviving return fire from 850 caliber machine guns was minimal. German fighters should use their superior maneuverability to force turning fights, should attack from angles where the P-47's guns couldn't be brought to bear, should hit and run rather than engaging in sustained combat. But even as he wrote these recommendations, Schulz knew they were admission of weakness. Tactical advice on how to avoid fighting an enemy aircraft was an acknowledgement that you couldn't beat it in a fair fight. As Schulz compiled his technical report over the following days and weeks, he began to see a pattern that went beyond any single component or system. Every aspect of the P-47 spoke to an underlying industrial capacity that was staggering. The engine required precision machining on a massive scale. The Turbo-Supercharger required advanced metallurgy and manufacturing capabilities. The airframe required vast quantities of aluminum. The armament required a functioning ammunition production industry capable of producing millions of rounds. Any one of these components would strain German industrial capacity. The P-47 had all of them integrated into a single aircraft and was being mass-produced at rates that seemed impossible. Schulz requested production data from intelligence sources. What he received was soul-crushing. Republic Aviation, the company that built the P-47, was producing these aircraft at rates that defied belief. By late 1943, they were building over 500 P-47s per month. Plans called for ramping up to 600, 700, even 800 per month by 1944. 800 per month. That was more than 9,000 aircraft per year, from a single manufacturer building a single aircraft type. For comparison, all of Germany's fighter production, combining Messerschmitt, Focke-Wulf, and other manufacturers, producing all fighter types, totaled perhaps 300 to 400 aircraft per month. And German production was constantly disrupted by Allied bombing raids that were becoming more frequent and more effective. But the numbers got worse. The R-2800 engine wasn't used only in the P-47. It powered multiple American aircraft. The F-6F Hellcat naval fighter used it. The F-4U Corsair used it. Various bombers and transport aircraft used it. Total production of R-2800 engines during the war would exceed 125,000 units. 125,000 of these 2,000 horsepower engines. Germany's entire production of aircraft engines for all types, including trainers and transport aircraft, across the entire war, would be roughly 250,000 units. Most of them were significantly less powerful than the R-2800. The Americans were building more of a single advanced engine type than Germany could produce total engines of all types. The disparity was incomprehensible. Schulz sat at his desk staring at these numbers. He ran the calculations again and again, thinking he must have made an error somewhere, that the intelligence data must be inflated propaganda. But the numbers didn't change. Different intelligence sources confirmed the same information. American aircraft production for 1943 was projected to exceed 85,000 aircraft. German production would be around 25,000, a ratio of more than 3 to 1. But it was actually worse than that ratio suggested, because American aircraft were on average heavier and more complex than German aircraft. A single B-17 bomber required more aluminum and more man-hours to produce than 3 Bf-109 fighters. The Americans were building thousands of B-17s, thousands of B-24s, thousands of P-47s, thousands of P-51s that would soon be joining the air war over Europe. The material disparity was overwhelming, in ways that went beyond simple numbers. America was fighting a global war. They were supplying the Soviet Union with thousands of aircraft through Lend-Lease. They were equipping British forces with aircraft and equipment. They were fighting campaigns in the Pacific, in North Africa, in Italy, and preparing for the invasion of France. And despite all of this, they were still outproducing Germany in every category. It wasn't just aircraft. American tank production dwarfed Germany's. American naval construction was on a scale never before seen in human history. American ammunition production was so vast that American units rarely faced the kind of ammunition shortages that plagued German forces. The United States had transformed itself into an arsenal the likes of which the world had never seen. Schulz's final report was due to be presented to High Command. As he compiled his findings, writing page after page of technical details and analysis, he knew he was creating something dangerous. The report documented the P-47's technical superiority in multiple areas. It acknowledged that Germany lacked the industrial capacity to produce equivalent systems. And most dangerously, it contained a conclusion that would certainly be seen as defeatist by the Nazi leadership. His summary read, "The P-47 Thunderbolt represents a level of industrial and technological sophistication that exceeds Germany's current capabilities. Its widespread deployment suggests American production capacity far exceeds previous intelligence estimates. Recommendation: tactical adjustments to minimize engagement with P-47 at high altitude. Strategic assessment: continued attrition against numerically and technically superior enemy aircraft will result in unsustainable losses. In other words, we can't beat this, and if we keep fighting the same way, we will be destroyed." It was a conclusion based on engineering analysis, on mathematics, on the cold reality of industrial production. But in the Third Reich in 1943, such conclusions were heresy. Schulz's commanding officer read the report with a mixture of respect and concern. "You know this will not be well received in Berlin," he said carefully. "They don't want to hear that American aircraft are superior. They certainly don't want to hear that we lack the industrial capacity to compete." "Should I alter the findings?" Schulz asked, already knowing the answer. "No," his commander replied. "The report is accurate. It's based on solid analysis. But prepare yourself. The leadership doesn't respond well to uncomfortable truths. This report will likely be filed away and ignored. Or worse, you may be accused of defeatism for writing it." The report was forwarded up the chain of command. Schulz never received an official response, but he heard through informal channels, through the network of engineers and technical officers who shared information quietly, that his report had been dismissed as overly pessimistic. One staff officer in Berlin reportedly said that Schulz had been demoralized by enemy propaganda, that the P-47 was crude American engineering inferior to German designs despite its size and weight. Another officer apparently claimed that tactical superiority and German fighting spirit would overcome any material disadvantage. The report, with its detailed measurements and careful analysis, was filed away, marked "No action required." Schulz wasn't surprised. He had seen this pattern before. Throughout his career in the Luftwaffe's technical services, he had watched as intelligence that contradicted Nazi ideology was rejected regardless of its accuracy. Reports about Allied aircraft performance were dismissed as exaggerations. Estimates of Allied production capacity were called propaganda. Assessments that suggested Germany was losing the industrial war were labeled defeatist. The Nazi leadership had constructed a worldview in which German racial and cultural superiority would overcome material disadvantages, in which willpower and determination mattered more than factory output, in which ideology could defeat mathematics. They were wrong, and men like Schulz knew they were wrong from the moment they examined the evidence. But in the Third Reich, knowing the truth and being able to act on that truth were two very different things. In the months following his report, Schulz watched his predictions come true with grim accuracy. P-47s appeared in increasing numbers over Europe. Initially, they were limited to short-range missions due to fuel capacity constraints. But as the war progressed, the Americans developed long-range fuel tanks that extended the P-47's range dramatically. Soon, there was nowhere over occupied Europe where German aircraft were safe from American fighters. The tactical recommendations Schulz had made, the suggestions about avoiding high-altitude engagements and using hit-and-run tactics, were slowly adopted by some Luftwaffe units. But by the time these tactics became standard practice, it was too late. The Americans had achieved air superiority through sheer weight of numbers combined with technical advantage. German fighter losses mounted steadily. Experienced pilots, the expert 10 who had survived years of combat, were shot down and not replaced. The Luftwaffe's training program, already stressed by fuel shortages and lack of aircraft, couldn't produce replacement pilots fast enough. Young pilots were being thrown into combat with minimal training, and they were being slaughtered by experienced American pilots flying superior aircraft. The death spiral had begun, and there was no way to pull out of it. Schulz examined other captured American aircraft as they became available. Each one told the same story. A B-17 bomber, one of over 12,000 that would be produced. Germany's entire heavy bomber force was a few hundred aircraft, mostly obsolete designs that had been converted to other roles. A C-47 transport plane, one of more than 10,000 that would be produced. Germany's entire transport fleet was a few hundred aircraft, mostly obsolete Junkers Ju-52s that were vulnerable to any fighter attack. A P-51 Mustang, which combined long range with even better performance than the P-47. The engine was a Packard-built Rolls-Royce Merlin, produced under license in America. Thousands of them. The British Merlin was a masterpiece of engineering. The Americans had taken that design, refined the manufacturing process, and were producing them on a scale that dwarfed British production. Every aircraft Schulz examined reinforced the same conclusion. Germany was losing an industrial war to an enemy with overwhelming material superiority. This wasn't about tactics or strategy or fighting spirit. It was about factories and resources. It was about who could produce more steel, more aluminum, more engines, more aircraft, more ammunition. And in that contest, Germany had already lost. What haunted Schulz was that this information was available to anyone who wanted to see it. The intelligence existed. German agents in neutral countries were reporting on American production. Captured equipment proved the quality and capability of American weapons. Economic analysts could see the disparity in industrial output, but the Nazi leadership refused to accept it. Or, more accurately, they accepted the reality, but believed that German will and superior tactics could overcome material disadvantage. They believed that ideology could triumph over industrial mathematics. Schulz had been trained as an engineer. He had spent years studying physics, mathematics, thermodynamics, and materials science. He believed in numbers, in equations, in physical reality that existed independent of what anyone wanted to believe. And the physical reality was undeniable. Germany was being buried under an avalanche of American steel, American aluminum, American engines, and American aircraft. No amount of fighting spirit, no superior tactics, no ideological fervor could change that fundamental reality. After the war, when production figures were declassified and became available to historians and researchers, Schulz's estimates were proven to be conservative. He had actually underestimated American industrial capacity. Total American aircraft production from 1940 to 1945 exceeded 300,000 aircraft. Germany produced approximately 94,000 aircraft in the same period. The United States produced over 15,600 P-47 Thunderbolts alone. That was more than Germany produced Bf-109s and FW-190s combined, their two main fighter types. One American aircraft type, built by one company, exceeded Germany's production of their two primary fighters combined. The R-2800 engine that Schulz had examined with such awe in 1943, the engine that had seemed like an impossible achievement in precision manufacturing, was produced in numbers exceeding 125,000 units. And it wasn't just built by Pratt Whitney. Ford Motor Company built them. Chevrolet built them. Buick built them. American automotive companies, with their experience in mass production, were retooled to build aircraft engines, and they built them to the same exacting standards that Schulz had observed in that captured P-47's engine. The industrial mobilization that produced these numbers was unprecedented in human history. American factories that had been making automobiles were retooled to make aircraft and aircraft engines. Shipyards that had built cargo vessels were building aircraft carriers. Women entered the workforce in massive numbers, replacing men who had gone to war. African Americans found opportunities in defense industries that had previously been closed to them. The entire society mobilized for war production, but unlike Germany, American civilians weren't starving. Unlike Germany, American cities weren't being bombed into rubble. Unlike Germany, American industrial capacity kept expanding even as the war continued. And critically, the quality remained high throughout the war. Late-war American aircraft showed no signs of declining standards. No shortcuts, no compromises forced by material shortages or desperate circumstances. A P-47 built in 1945 was just as well made as one built in 1943, maybe even better as manufacturing processes were refined. German aircraft, by contrast, showed increasing evidence of resource constraints. Lower-grade materials were substituted where better materials should have been used. Manufacturing was simplified to save time and labor. Quality control suffered as experienced workers were drafted and replaced by forced laborers who lacked the skills and had every reason to sabotage production. The disparity in quality grew even as the disparity in quantity became insurmountable. Schulz survived the war. In the chaos of Germany's collapse in 1945, as the Reich crumbled and the Allies swept across Europe, Schulz was captured by American forces. He was interrogated by American technical intelligence officers who were very interested in what German engineers had learned from examining captured Allied aircraft. They were particularly interested in his 1943 report on the P-47. Did you really conclude from examining one aircraft that Germany would lose the war? An American intelligence officer asked him during one interrogation session. Schulz thought carefully before answering, aware that even though the war was over, his words would be on record. "I concluded that Germany could not win an industrial war against America," he said finally. The P-47 was evidence of a production capacity we couldn't match. Every component, every system required resources and manufacturing capability that exceeded what Germany could sustain. One aircraft doesn't tell you everything, but that one aircraft represented a level of industrial capability that was beyond Germany's reach. "But you were just one engineer," the American officer said. "Surely others in Germany reached the same conclusion." "Many did," Schulz replied. "Engineers, economists, military planners. Many people understood the reality of Germany's industrial situation. But in the Third Reich, stating inconvenient truths was dangerous. It was safer to remain silent than to be accused of defeatism. And even when people did speak up, even when accurate reports were submitted, they were dismissed if they contradicted the official narrative." The American officer nodded, making notes. "We found your report in the captured German files," he said. "It was marked filed, no action required. Did that surprise you?" Schulz laughed, but there was no humor in it. "No, I expected it. The Nazi leadership didn't want intelligence that contradicted their worldview. They wanted validation of what they already believed. When reality contradicted ideology, reality was dismissed. That's one reason why Germany lost. Not the only reason, but an important one." The story of Werner Schulz and the captured P-47 is more than just an interesting historical anecdote. It's a microcosm of Germany's strategic failure in World War II. A trained engineer examined enemy equipment, reached accurate conclusions about Germany's industrial disadvantage, reported those conclusions through proper channels, and was completely ignored because his findings contradicted the prevailing ideology. His experience paralleled that of many others. Admiral Wilhelm Canaris, head of the Abwehr, Germany's military intelligence service, had warned about American industrial capacity before the war even started. His reports were dismissed. Albert Speer, who took over as Minister of Armaments in 1942, knew that Germany couldn't win a production war against the combined Allied powers. He tried to maximize German production, used slave labor on a massive scale to squeeze every last bit of output from German industry. But even his so-called armaments miracle was insufficient. It was already clear to Speer by September 1942 that the war could not be won with the means available. Instead of seeking a political solution, the Nazi leadership doubled down, intensifying and radicalizing the war in the desperate hope of changing the tide through willpower alone. Adolf Galland, one of the Luftwaffe's most successful fighter pilots and later general of fighters, recognized the P-47's tactical superiority. He understood that the Luftwaffe was being overwhelmed by superior numbers of increasingly capable aircraft. His warnings were heard but not heeded. The response was to demand more fighting spirit, more aggression, more sacrifice, as if determination alone could overcome material disadvantage. Sepp Dietrich, commander of the 6th Panzer Army, knew that the Ardennes offensive in December 1944, Germany's last major offensive operation in the West, would fail due to lack of fuel. The panzers would run out of fuel before they reached their objectives. He was right. But the offensive was launched anyway, based on Hitler's belief that a major victory would change the strategic situation, would split the Western Allies from the Soviet Union, would force a negotiated settlement. It failed, exactly as predicted, for exactly the reasons that had been identified beforehand. In every case, competent professionals saw the reality clearly. Engineers, military officers, economists, and intelligence analysts understood Germany's strategic situation. They provided accurate assessments based on solid evidence and sound analysis. And in every case, they were trapped in a system where truth was subordinate to ideology, where inconvenient facts were dismissed as defeatism or pessimism, where reality was denied because accepting it would mean admitting that the war was unwinnable. The Nazi regime was built on the premise that German racial and cultural superiority would overcome any material disadvantage. That will and determination mattered more than industrial capacity. That ideology could defeat mathematics, that spirit could triumph over steel. They were catastrophically wrong. And the men who knew they were wrong, who had the evidence and analysis to prove they were wrong, were powerless to change the course of events because the system they served valued ideological purity over truth. Schulz's report on the P-47 should have been a wake-up call. It should have triggered a fundamental reassessment of Germany's strategic position. A serious government, one that valued reality over ideology, would have looked at that report and asked hard questions. Can we match this level of production? If not, can we win a war of attrition? If we can't win a war of attrition, what are our alternatives? Is there a diplomatic solution? Is there a way to end this conflict before we're completely destroyed? But those questions were never asked. The report was filed away and forgotten because asking those questions would have required admitting that the fundamental assumptions underlying Nazi ideology were wrong. The P-47 Thunderbolt went on to become one of the most produced fighters of World War. T-47 over 15,600 were built. They destroyed thousands of German aircraft. They supported the invasion of Europe at Normandy and the subsequent campaign across France and into Germany. They helped achieve the air superiority that made Germany's defeat inevitable. They flew over 500,000 combat sorties, one of the most extensive combat records of any aircraft in history. They earned a reputation for ruggedness and reliability that became legendary. Pilots who flew them came to love the big fighter for its ability to absorb damage and bring them home alive. And it all started with one engineer examining one captured aircraft in France in August 1943, and realizing that his nation had already lost a war they didn't know they were fighting. Not a war of soldiers or tactics, not a war of courage or determination, but a war of factories and resources. A war where the side with more oil, more aluminum, more steel, more machine tools, and more industrial capacity would inevitably win. America had all of those things in abundance. Germany had none of them. The mathematics was inexorable. The outcome was predetermined. All that remained was the grinding reality of attrition, of month after month of losses that couldn't be replaced, of experienced pilots shot down and replaced by inexperienced boys, of aircraft losses mounting faster than production could replace them, of fuel shortages that grounded fighters even when pilots were available, of a defense that grew weaker month by month while the attacking force grew stronger. Werner Schulz knew all of this in August 1943 from examining one aircraft. He knew it from the precision of the engine machining. He knew it from the quality of the materials. He knew it from the sophisticated Turbo-Supercharger system that Germany couldn't replicate. He knew it from the heavy armor and robust construction that spoke to unlimited resources. He knew it from the massive firepower that reflected an ammunition production capacity beyond Germany's reach. Every rivet, every aluminum panel, every component told the same story. Germany was fighting an enemy with industrial capacity on a scale they couldn't match. He wrote his report. He submitted it through proper channels. He documented everything with the thoroughness of a trained engineer, and it made no difference whatsoever. The report was filed away. The war continued. The predictions in the report all came true. And when Germany finally surrendered in May 1945, in the ruins of Berlin, with Soviet troops fighting street by street into the heart of the city, the reasons for defeat were exactly what Schulz had identified nearly 2 years earlier. Industrial capacity, material superiority, mathematics. The engineers had known. The intelligence officers had known. The economists had known. But in the Third Reich, knowledge without the power to act on that knowledge was worthless. And the people with power refused to see reality because seeing it would have meant admitting their entire worldview was wrong. So they pressed on, demanding more sacrifice, more fighting spirit, more determination, even as the material reality of industrial mathematics ground them down month by month, battle by battle, until there was nothing left but rubble and defeat. One captured P-47, examined by one German engineer in August 1943, told the entire story of why Germany would lose World War II. Not because German soldiers lacked courage, not because German generals lacked tactical skill, not because German engineers lacked brilliance, but because Germany entered an industrial war against an enemy with overwhelming material superiority, and no amount of courage, skill, or brilliance could overcome that fundamental mathematical reality. Werner Schulz understood this truth in August 1943, and it made absolutely no difference at all.